Dear students, today we are going to prove a very important relation which is called Wheatstone Bridge principle, which is giving the relation between the two resistances given on one side of the arms and another two resistance given on the another side of the arms, and when no current is flowing in between the central path which is called bridge. So let us see what is Wheatstone Bridge principle. It says that if a bridge is balanced, means you see what is bridge, you all know that it connects the one side of the river with the another side of the river. So just like that, if this is another one side, arm ABC is one side of a circuit and arm ADC is another side of the circuit, then the two sides are connected through a galvanometer, and that is taken to be as a bridge. So when we have a balanced state, means the no current is flowing through the galvanometer. That means if the current through the galvanometer may be termed as Ig, then that is taken to be 0. If that is the case, then for that we have this Wheatstone Bridge principle, which states that for a balanced bridge, that is current through the galvanometer, that is the bridge is 0, we always have ratio of resistances of two arms on one side of the bridge, that is arm ABC you see in the diagram, is equal to the ratio of resistances of other two arms on the other side of the bridge, that is arm ADC. So this statement is true, means the ratio of P by Q, the ratio P by Q is equal to ratio R by S. This is only true when no current is flowing in between the arm BD, means the galvanometer current is 0. If that is true, only then we have this relation P by Q is equal to R by S. Otherwise this relation is not valid. This relation is valid only for a balanced bridge. Here you see where P, Q, R and S are the resistances of arm AB, BC, AD and DC. And for a balanced bridge we always take current through the galvanometer. Why we say galvanometer? Remember, galvanometer is a current detecting device and it detects even the smaller current flowing through it. So that way, if no current is flowing through the galvanometer, it will show no deflection, and that means no current is flowing through it. So that becomes helpful to us to confirm that no current is flowing through the arm BC. Therefore, we use galvanometer. Now, what for the proof we take that galvanometer current is 0, is taken to be 0, and this state is called balance bridge. This state is called balance bridge, and for that current I1 in the arm AB must be equal to current in the arm BC. You see, when say for example we the cell is delivering current I1 plus I2, let us call it, say, total current I is equal to I1 plus I2, then and some current is flowing through arm AB, let us say I1, and the remaining part of the current is flowing through arm AD. Now we have taken that point, no current is flowing between the arm BD. That means the potential at B must be equal to potential at D. And for that matter, we can always write that I1 P1 must be equal to I2 R, because A is having a common potential at this end and no current is flowing across the point BD. Therefore, potential at B must be equal to potential at D. That means whatever drop is taking place across arm P, resistance P, same potential drop must take place across the resistance R. So we have potential AB is equal to potential across AD, and therefore we write potential across AB equal to potential across AD, and for that value we can use the relation V is equal to IR. So we have VAB is equal to I1P equal to, and VAD is equal to I2R. Now no current is flowing through the BD, so the potential at B and potential at D are same, and C is common point to both these arms BC and DC. So again we can say that potential drop across BC equal to potential drop across DC. Therefore we can write potential drop across BC equal to potential drop across DC. And for this potential drop we can write it in the form of V is equal to, using the formula V is equal to IR, we can write VBC is equal to I1 into Q, and VDC is equal to I2 into S. I2 current is flowing through this arm. Now why we say only I1 current is flowing through BC? Because if some current is entering the arm AB and no part of it is going across BD, then the total current, same current must flow through the arm BC. Similarly, some current is entering the arm AD, say I2, and no current is moving across BD, no part of that is moving across BD. So the total current, same current will flow through the arm DC, and therefore we can write I1 into Q is equal to I2 into S. And using these two relations, if you divide equation 1 by equation 2, what you see, I1 and I1 cancel each other, I2 and I2 cancel each other, so we are left with P by Q is equal to R by S. P by Q is equal to R by S. This is what we have to prove, and this is called Wheatstone Bridge principle. It is very useful. Wherever the bridge is balanced, we can use this relation and find the unknown resistance. Usually we use it to find the unknown resistance, that is Q, and the other resistance are known to us or could be determined. So this is the famous Wheatstone Bridge principle we have just proved. And apart from this, whenever this type of bridge is given to you and if it is not balanced, then we need to apply the Kirchhoff's law, which we have just read in the previous lecture. And for applying the Kirchhoff's law, you have to remember we have two rules, Kirchhoff's rule. One is junction rule and another is loop rule. So that will be helpful. Wherever we don't have a simple circuit, we can always apply the Kirchhoff's law to solve our problems related to electricity. Thank you and have a nice day.